Let's try another example of a horizontally launched projectile. Here we go. Determine the launch speed of a horizontally launched projectile that lands 26.3 meters from the base of a 19.3 meter high cliff. Before solving the problem, draw a picture and label all givens on the picture. All right, so here's going to be our cliff above ground. We have some horizontally launched projectile. It could be a ball, it could be an arrow, it could be all sorts of things. And it's going to get launched out this way and it's going to fall to the ground below. And we know that this height here is 19.3 meters. And we know that it lands 26.3 meters away from the base of the cliff. And we're being asked to find this initial horizontal velocity that it was launched out from, right? This vector. So in our problems, we're going to call this delta x. We're going to call this delta y, okay? 19.3. So let's do this in two steps. First, let's find out how long it takes this projectile to fall and hit the ground. We're going to find the falling time. Okay, so remember in projectile motion, projectiles are falling while they're being launched horizontally, while they're moving horizontally through the air. So the horizontal motion does not affect how long it takes to hit the ground. This particular projectile would reach the ground at the exact same time as if it was just dropped straight down. Okay, so we can ignore the horizontal motion and just focus on the fact that it's 19.3 meters above ground. And let's try this approach. This is the first equation in the vertical direction. So this is the initial vertical velocity, the vertical acceleration. So the delta y is actually going to be negative 19.3 meters because it's falling. The initial vertical velocity, well, we're told it's a horizontally launched projectile, right? So the initial vertical velocity is 0. It's not being thrown up or down. It's just being thrown outwards to the right. So this is 0 times t. That's going to go away. Plus the acceleration in the vertical direction multiplied by the time squared, okay? So the right side simplifies to negative 4.9 t squared. Divide both sides by negative 4.9 t squared, take the square root, and you get that the falling time is 1.98 seconds. Now that we know here, right, the time at this particular moment, 1.98 seconds, that's when it hits the ground, we can figure out how fast it must have been launched outwards so that it travels this distance in this amount of time. Let's try. Step 2. To find v initial x, right? The initial horizontal velocity of this projectile. We're going to use the fact that delta x equals v initial x times t plus 1/2 a t squared. Remember, projectiles do not accelerate horizontally because when they're flying through the air horizontally, there are no horizontal forces on them. Gravity is only a vertical force. So the horizontal acceleration is 0. The horizontal acceleration is 0. So this whole term goes away. And then I can easily solve for the horizontal velocity. 26.3 meters is the range. The time is 1.98 seconds. And so it must have been pushed out at 13.28 meters per second when it was launched.